Um, okay, cool. So let me just get the book here on the screen. So I believe we have both, I mean, Tal, Douglas, and Eero joining for the first time. Maybe if we can have a quick intro, if that's okay, within 1 minute, 30 seconds intro. You quickly do that. Where are you from? Where do you work? And what's your role? That would be helpful. And I can start. My name is Nipendra. I'm in Bangalore, India. And we train people on containers, Kubernetes. I'm also a CNCF ambassador. Yeah. Um, Pushpjeet, can you go
So,
next? Yeah, sorry. You can still can't hear you, Pushpjeet. Sorry. You have to type. Go ahead, tell. Yeah.
okay, I'm Tal. I'm working as a solutions architect in Lightrun. It's an observability platform, and I worked before that in JFrog. I was a DevOps engineer and also solutions architect there. Very passionate about Kubernetes, Argo CD, Argo rollouts, the
Mhm.
CNCF project. And basically, I came here to to meet people and to learn and to participate.
Thank you. Douglas?
Hello, I am Douglas Luna. I am from Brazil and I work as a cloud security specialist in a company named DASA, that is the biggest healthcare and diagnostic company in Latam. And I am currently working with cloud security, Kubernetes, and incident response.
Okay, thank you. Abdul, quick intro.
Hey guys, my name is Abdul Kareem. I'm from India. I run a small DevOps SRE consulting company, and yeah, here to learn and read books and meet awesome people.
Cool, thank you. Hero, if you're there.
Yeah, I'm from Finland and I work for a company called Codento, which is a Google partner company. And yeah,
Okay,
I've also worked with Kubernetes and around full stack developer, including DevOps and so on.
okay, cool, thank you. Then we just left with Ram Kumar and
Ram Kumar, I'm from Oman. I'm working in a college. Yeah,
so you teach there. How is it, Ram Kumar?
yeah. I'm teaching here. I work
Okay.
in I work in a IT department.
Okay, okay, that's nice. And you're teaching Kubernetes there, is it?
No. It's out of my interest. Like I'm just learning myself.
Okay, cool.
Using in some of my projects, like for my research work and other aspects.
Okay, nice, nice. Valdemar, good to have you. Happy New Year.
Happy New Year.
Valdemar, a quick intro. If you're available, you can speak up. Okay, if not, then we'll get going. Anyone else we missed? Pushpajit, can you still try? I don't know.
Hi, can you hear me?
Yeah, I can hear you. Yes, Valdemar, yes.
Hi, Hi everybody. My name is Vladimir. I'm from New York. Originally, I am from Ukraine, but currently in New York. I work for Oracle, and I work with Kubernetes and day-to-day activities with OKE and yeah, and other stuff.
Cool. So we have two guys um, from New York today. Nice.
I think
Uh,
now, Dipendra, you will be able to
yeah.
hear.
Yes, yes, correct. Go ahead, Pushpajit.
Right. So my name is Pushpajit. I'm a corporate trainer. I'm into Oracle database. So I worked as a SQL developer, PLSQL developer. I worked as a DBA also. And currently, I have done this AWS Solution Architect Associate
Okay.
certification. Like it's 3 years back, but now it's time to recertify recertificate I have to do. And last month only I completed Dockers, and also now I'm having a little bit about the Kubernetes, but I just want to know more. And my aim is to do the certification for the Kubernetes. So that's why
Okay.
yeah, I'm very much interested to know more about Kubernetes. And CNCF, yes, I want to explore more about this community, want to contribute also. So that's why I joined this.
Okay, cool.
Thanks.
Just give me 1 minute. Yeah. Okay, cool. So now, as some of you for the first time, we are reading this Production Kubernetes book. If you don't have a copy of it, it's part of the invite. You can get a free copy of this book. So we have finished 9 chapters, I think over, I don't know, 4 months now, 3 months at least. When we started, do you have a date, Abdul? When did we start our book club for this time zone?
Yeah, it should be in the doc. Just give me 1 minute.
Correct. Yeah. So it's been a while we have been doing this, and this is the first book for this particular time zone. There's one more session that happens on Friday. That is a bit too late for at least for this time zone what we are in. So we thought of having an parallel sessions on this time at this time zone. Right. So 24th August, yes, has been close to 5 months now. So the next chapter we were doing is identity. This is the chapter which you see on the screen. Um, what we covered last time is that let me quickly go over. Yeah. So we cover authentication, authorization, a bit of overview of that. The main thing what we saw last time were that in Kubernetes there is no object called user per se, and then Kubernetes does not have like a pod like we have a pod object. We don't have a user object, right? It is kind of done intentionally because companies are going to have their own way of having users authenticated. So why to kind of reinvent the things? And that is why Kubernetes does not have, but it connects well with single sign-on, the OIDC, LDAP stuff. That's something which we kind of talked about last time. Um, the few things which we saw earlier is the important one is that when we authenticate a user, we authenticate by having the basic authentication. Like there can be a configuration file which can contain users name, password, and the UID, GID kind of a thing, and that can be given to the API server, so that whenever somebody logs in, API server can verify that. But that is not kind of a secure way or a good way of doing that. So then we saw that we can use the PKI method. So basically we can use the public key infrastructure there. So what happens when we configure Kubernetes, it creates its own PKI. So I believe all of you would have seen etc Kubernetes um, PKI folder, I think. Yeah, that's the folder there, where you will find all the different kind of key certificates are there. So what we can do is we can have our users, and these users can generate their private key and the public key, and then we can get certificate signed by the Kubernetes CA. So if Kubernetes CA can sign that particular request, then I get certificate which is verified by the Kubernetes. And that way we can allow the users to log into the Kubernetes cluster, right? That is something what we saw in detail last time, and we also covered the demo of it. So if you have not watched, I believe the recording would be on the channel, which you can take a look. So this is the entire process. Um, I'll not go over, it will take some time, but what I discussed, that's what it is, right? That you try to get certificate from the Kubernetes CA, and when the user try to logs in, it can give the certificate which can be verified by the Kubernetes CA, and then it can continue the kind of flow of authentication and then authorization and so on. So that's something what we covered very deeply last time. So there is a very good demo which we did. So try to watch the video if you can. Okay, but there was a problem with the certificate way of doing authentication, because once you create the certificates, you cannot easily kind of expire them. So, for example, if you have a user, and for that user you get a certificate from the Kubernetes, right? And that user, let's say, leaves the company in between, but that certificate would still be valid, correct? So that can be a bit challenging task unless you kind of rotate and all other stuff you have to do to kind of manage that. So that's a challenge what you may face if you use the certificate way of managing authentication for users. I hope it makes sense. Any questions? Okay, fine. So, but the better way of doing it is by doing a single sign-on. I think all of you know that we can sign into our applications by um, Okta, by Google OAuth, and other stuff. So similarly, what we can do is we can also configure our Kubernetes cluster to do authentication via some of these mechanism of Okta, Auth, Zero Google, and LDAP other ways as well. Correct. So that is what we can easily configure on with Kubernetes. So when a user logs in, it would authenticate via the Okta or Google, and once that happens, it can go to the next step as authorization. So just to bring to the point that there are three stages when we make or when we work on a given object, right? Authentication, authorization, and then admission control. These are the three stages through which all the request goes through. So when somebody logs into the system, it does not mean that user has the permission to perform anything, correct? So you do authentication, and then authorization can be done with the RBAC in Kubernetes terms, and then only the user can perform different operations. And that is why we can offload authentication to different methods, correct? And that is how it is being done. And then if you have to do multiple of these, like a fallback plan, for example, if Okta fail, you go to Google and all that stuff, right? There is a project called Dex, which you can use. So somewhere it was mentioned, which you can configure. So you can have multiple of these systems configured, and then you can do that as well, correct? So this is the kind of flow which is being mentioned here. So what is happening is user is trying to log into the provider. Think about Google OAuth, right? So we kind of user logs in, runs a command, say kubectl get pods and so on. Then as the command runs, we would open a browser interface. In the browser, depending on the OIDC configuration, then we provide our credentials, whatever are there, and then that particular provider is going to give you a token, and that token becomes part of your kubectl, kubectl, right? So if you know the kubeconfig file, in the kubeconfig file, we would mention that. So I don't have it handy, but let me please search if I can search and get it. So kubeconfig OIDC token. Let me just check. Yeah, something like this it would come. I'll just share my screen. Yeah, I'll bring it here. Yeah. So as you can see, what is happening here is, I mean, this is like an example we just got on the internet. But something similar you will see, right? So for example, in the kubeconfig file, or let me see if I can get better one. Yeah, this is better. Yeah. So what can happen is in the kubeconfig file, what we have in the kubeconfig file, we'll configure like this. So what's going to happen in this case is we are defining that how would I connect to the given OIDC provider. So you run the command called kubectl get pods and so on, and based on these parameters. So for example, this is your Google OAuth endpoint. Then you give your whatever the client key and all that stuff is there. And then as the Google OAuth logs in, you provide your Gmail credentials or whatever is there. And then because the authentication happened successfully there, it would give you a token back. And that token then become part of the further request. Correct. So that is what is happening here. Token. So we get that particular token, and now with the kubectl, we would send it to the API server, as you can see here, and then further checks would happen whether the given token is valid or not, whether it is expired or not, and then whether it is authorized or not, whether the user is authorized or not. And if all these stages are passed, then the request would come back to the user and the given operation would be done. Any questions on the flow or anything you want to add? Anyone who has done it earlier? Anybody configured OIDC in your company or any for a client? No? Okay. Fine. So again, don't treat me as an expert. I'm also a learner here. So any questions, any discussions, please bring them on. Yeah, that would be helpful.
Yes, I've not done it manually, but I think the IRSA provision in AWS, the IAM roles over service accounts, does this behind the scenes.
Yeah, I think something is being covered later in this particular chapter, which I am yet to finish. But yeah, something I have heard. So yes, correct. So I have done it locally with Keycloak once. But yeah, I have not been extensive user of AWS yet. Yeah.
It's usually a one-time thing, and
Yeah.
the open source installers like the Terraform module, etc., they kind of take care of doing this for you.
Okay. Is it okay? Terraform can take care of it. Okay, that's nice. Okay. Fine. So of course, this is the best way of doing things because at a central place, if I disable the user from my company, it cannot access the Kubernetes cluster anymore, right? So this is the preferred way of doing the authentication in the Kubernetes world. Just give me a minute. I'm just going to get my notes. Yeah. Meanwhile, any other points you want to bring in? Yeah, I think Dex was mentioned here. So you can use Dex if you if you want to aggregate multiple providers. The Dex can be used to serve different or kind of have multiple providers in the chain of authentication. Okay, good. So yes, as I was mentioning, right, it kind of try to open a web interface. So I believe we all know that if we log in to any of these solutions, when we use it, right, it is going to open a web interface. In that, we were going to provide our credentials, and then we can log in. This is perfectly fine for the end users, but it can become a bit challenging if I have some kind of a robot, for example, our pipeline of CI/CD, right? If that particular user or robot want to connect um, to the single sign-on, it can become a bit challenging because if it opens a web interface, how would my CI/CD system can log into that web interface and provide credentials? So that can be a kind of bit challenging there. Now, there are a couple of ways by which this problem can be solved. That is what been mentioned here. The one thing is that we can configure a webhook. That webhook basically, so whenever the CI/CD want to authenticate to the API server, it basically reaches out to a webhook, and then that webhook responds back to you um, with the success or failure. So that way we can do that. Then other method is you can use the certificate-based method, which we discussed earlier, that you can generate certificates for every robot of yours, or for example, agent of Jenkins and so on. and that can be done as well. But the problem remains the same, that you have to manage certificates, issuance and rotation very carefully there. That is what been mentioned here. The other method is mentioned here is by doing the service account method, so which we'll explore a bit later. So what we can do is we can have the service account. So in simple terms, service accounts are the users used by a program. So for example, think about your Kubernetes dashboard app. Now Kubernetes dashboard app eventually has to connect to the API server. So how does this dashboard app talk to the API server? Is via the service account. So we create these users which are going to connect to the API server on behalf of the programs we are running. So we can use that method to basically have the authentication done for our users. Any points? Anything else you want to add? So I believe Tel was saying that he was using Argo CD, right? Argo CD, right? So for Argo CD, have you checked out how does the Argo CD talk to the API server and get the work done?
So we used SDM in my former company. We used SDM to manage the access to the clusters. So we just
What was
provided
SDM? Sorry, come again.
we used SDM. It's a solution to manage like access to Kubernetes clusters. So it's
Can you
called
just point it to it?
DM. It's called Strong DM. I'm putting the link here
Yeah.
on the chat.
Okay.
And every access to the cluster was via Strong DM, and then Strong DM had the mechanisms of like users and role-based access control and everything.
Okay. So I have not used this thing earlier. Okay. Okay. Strong DM. Okay. Okay. First time I'm hearing this, but yeah, some of these things are there. Anything else? I mean, anybody has heard about anything like that or using in your environment? So even the Argo CD done by the SDM, this one is only strong DM.
It has like an extension, like we can run as a sidecar, a container that is running, the Strong DM part, and then it
Okay.
used to all authentication for Argo CD to the all clusters. The reason we needed Strong DM is because we had like around 90 clusters, so it was hard to manage every individual one. So we had this single source of truth
Okay.
for managing all clusters in one place. This is why we choose StrongDM.
Okay. Okay. Understood. Understood. So it is a computer of HashiCorp Vault, is it? Something like that?
No, I think it's on his own. Yeah, I think it's on his own.
Yeah, it's on its own, but I'm saying is a competitor of. It's like you can use HashiCorp Vault or StrongDM, is it?
I'm not sure if HashiCorp Vault is also option. Not sure.
Okay. Okay. No problem. Okay. Anybody else want to bring up any other point here?
What does Argo CD use by default?
It should use service accounts only, I believe, right? And RBAC policy. So what I recall is it kind of creates it kind of gets a cluster role, and then it kind of does all the things internally after that. That's what I recall, but yeah, maybe wrong. We can quickly check. Hmm. Not this file. Anyway, we can installation. We just look at the installation file move once, and then
So I think Argo CD uses service accounts.
Yeah, that is what the account would be using it. So it would be getting the service accounts, and then you give the role to it. So cluster role is being
Yeah,
used
exactly.
here. Yeah, right. That's how we work. So
So if you use strong DM, I'm guessing that should also be using service account behind the scene, right?
mm,
I
so
guess
authenticate. Sorry.
I'm not sure what's the implementation. It's just like they have a nice UI,
Mm-hmm.
and it's like it's helpful, when you have a lot of clusters to control everything in one place.
Mm-hmm.
Uh, this is the reason they choose strong name.
Okay. Okay. Makes sense. Makes sense.
So what kind of operations do you do via the strong DM UI? Like, do you manage access for Argo CD controller, or is it for the users that log in on Argo CD?
No, so you just give so it's just one gateway for accessing all the clusters, and if some developer needs access to maybe just two clusters, you can manage it from strong DM.
Got it. So it's basically for the users on Argo CD and manage access for
No,
them.
no. It's for generic access to the clusters. It's for generic access to the clusters, but then you can just use a strong DM URL for a
Mm-hmm.
cluster and put it in Argo CD, and then
Mm-hmm.
create a service account for Argo CD to use
Mm-hmm.
for strong DM, and then it's like Argo is accessing
Oh,
these clusters via strong DM, and that's it.
okay. Interesting. I'll probably read up about this.
Yeah,
Yeah.
but I
Yeah.
think that it's not like there are a lot of solutions. It's not that it's the best solution or something. It's just what my company used. So
Yeah.
Mm.
No, it's good to know actually, right? As a learner, we should be aware of what is available in the market, right? So good. Thank you for bringing it up. Please, others also bring in the points whenever you kind of see the. I mean, all of the discussions, right? Very helpful. Okay.
So at this point, I would like to ask, like, I have come across one product called Lens. Is it something related to it, or it is totally
Lens is only for, I think, monitoring, right? So it
okay?
basically you
yeah,
add the lens and it kind of
Lens is just for viewing the
viewing it.
objects. It's just for viewing the objects, logs. You see the different Kubernetes objects, and you can
Hmm.
see them in a nice UI in a nice way.
Correct, correct. Just a
Oh,
UI, like a better dashboard in a way, I
okay,
would say. Okay,
okay,
good.
okay. Thank
So
you.
the next is now um, the point is the next is implementing the least permission for users, right? So that is something which is very important for any company or any org which is there, right? That how I can give the least permission to the users so that they can do only what is required for them to be done, right? Not that they can do like not every user kind of need to be an admin user per se, right? So, for example, I can say in this particular team, you can perform such as that operation. So we can um, do um, do those things as well on Kubernetes as well. So, of course, for that purpose, we have this RBAC policies, which has already been in place. But there is one thing very interesting which I came across with this book is impersonation, right? So like the way we have the sudo users in Linux. So for example, if I'm a sudo user, I can write sudo apt install whatever, right? So typically, if I just run the command as my username, I cannot perform that installation process. But if I use sudo in front of the command, given that I am one of that sudo user, I can then install a given package because my permissions are kind of say elevated for a given time frame. So for that time, I can just elevate myself to the root user and perform the operations and come back. So something similar we can also do within Kubernetes as well. We can basically have let's say there is an ops group, for example, right? Now, typically, the ops user group, which are the users are in that group, they cannot perform elevated operations. But if we give them impersonation as a cluster admin, then they can perform the more privileged operations in a way there. So that's something which we can do within Kubernetes as well. So let's have a look at how it has been done, how it has been shown in this particular book here. So one thing that is mentioned here is, in this case, we have the group called ops team. So basically think about, there are 10 users who are part of this ops team group. And we talked about how to define the group in the previous session. So like in the case of when you create these certificates, you can put them CN common name is the username. And then I think we have this O, organization, that is a group name when we create these certificates, right? So in that O is the group or organization, right? So we are saying that all of the users who have that O settings done as a ops team, they become part of this ops team group. Now, what we are saying in this cluster role binding, so all the users who are part of the ops team group, they have the view access. So cluster role and view, this is what is mentioned here, which means that anybody who is in the ops team, that user can look at all the objects in the cluster. That is what this particular YML means. Now, what this particular example telling next is, we are going to create one more cluster role binding, in which we are saying the user cluster admin is having the cluster admin role. So basically, now this cluster admin user would have all the permissions in the cluster. That is what this particular thing means. But this is very interesting here now, this point. Now, what we are saying is, there is a verb called impersonate. So what does it saying that I'm creating a cluster role for all the users with the verb impersonate as a cluster admin, and it is given to all the people who are part of this group. So what we are saying is, all the people who are part of this ops team group, they can impersonate as a cluster admin. Does it make sense? So now what
Yeah,
happens with, yeah.
Can I ask a question? Why is this useful? Like, what can it be useful for? For
See, for
example.
example, if I give you like the simple thing, right? Uh, think about, you logged into an Ubuntu machine, right? And then you go to cd slash, and then you do rm minus rf. Can you do it as a normal user?
Okay, yeah, I understand.
But as a root, you can definitely do. Correct?
So it means you don't want to really give them cluster admin, but maybe just for a period of time or as a
Yes.
pack for 1 hour, you can allow them to impersonate admins, and then you maybe change it.
Yeah, so basically they are very sure that why somebody is doing it, right? So for example, if you give the same kubeconfig file for the Kubernetes admin user, for example, right? So if you look at your kubeconfig file, in that it mentioned about the username is kube-admin, correct? Now, if
Yeah.
you give the same kubeconfig file to 10 users, and if they perform the command of whatever, delete something, right? Now, in the audit logs, what you will see, kube-admin user has done that.
Yeah.
But who has done it in the team, you're not aware of it, right? Makes sense, right?
Yeah, I understand.
So, but now in this case, what we are saying, first of all, we are not telling that all of the users you have admin access. You have, but you have to impersonate that you want to become. And when you impersonate, what's going to happen is, in the audit logs, it would be mentioned very clearly that who has done it. Correct? So if I look at the logs, I can see that this person has impersonate as a root user and perform this particular command. So it's a very important, I think, concept in the Kubernetes terms. Now, this can be not just for the cluster admin, it can be done within the namespace also. So for example, within a namespace, you can have certain users who can have privileged access. For example, some of the users can create, let's say, the load balancers, while others cannot. Correct. So even you can have such kind of impersonation done within the namespace as well. Hope it makes sense, right? Yeah, so the example what is being given here. So for example, I'm trying to create a config map here. As you can see, it is saying that config map is forbidden for user John. So user John cannot create the config map. But then I say kubectl as cluster admin. So now this John user is becoming cluster admin for a time being and try to get a config map. So it can do now. Make sense? So now when we look at the audit logs, it would become very clear that it is being done by the John who became the cluster admin for a time being, created the config map and then came back. Great. Anything anybody wants to add? Has anybody done this earlier at all within your org, or have you seen it earlier? This kind of impersonation on Kubernetes?
Not really, but again, I take the AWS example. I guess this is very similar to the AWS assume role feature that they have, right?
Correct,
To
correct.
assume a particular role.
Yeah, similar to sudo only, correct.
Yes.
But it's very important, right? Because the problem is same, right? That same you can
Yes.
add a user to a group, and then of course you just don't give them admin just like that, right? You tell them that you have to elevate yourself and then do it. And then in the audit logs, you can clearly see that it has been done by this user. So, yeah.
Correct.
Anyone want to add anything on that? So what, of course, this seems useful, but any other use case you can think of where this can become a game changer? For example, platform engineering is coming, right? Platform engineering, what we know that it's going to be kind of give you all the nice UI and all those things where you can create. So there we can use this feature a lot, I believe, right? You can add the user into a group and then, of course, same thing, right? What is being mentioned here. So impersonate and then perform something and come back, right? Okay, cool. Okay. The next point here is how we can identify a given application or a workload. Right now, why this is very important, right? Because you want to make sure that whom do you connect to, you are doing the connection to the endpoint which you intend to, right? So it should not happen that though you make connection to the backend, but somebody else replied back to you and all those kind of things, right? So you want to kind of identify endpoints very uniquely to basically, of course, put some policies. At the same time, make sure that you talk to the right endpoints. All those things are important here, right? So workload identifying themselves to other workloads within the cluster. Um, so 1 minute. Yeah, this was mentioned that it was for human users. Now, how we can do for the workloads, right? That's what we mentioned here. So workload identifying themselves to other workloads. That's what the point here. That I want to make sure that I talk to the service of backend only. Or for example, there is a connection between the logistic and the payment, right? And I really talking to my payment endpoint for sure. So how I can make sure that. Um, then workload identifying themselves to obtain the appropriate access for the Kubernetes API itself. So for example, the dashboard application, right? Dashboard application need to talk to the API server. So how it will identify itself. Then also we can also put up like how the workload identify themselves and authenticate to external services like AWS, GCP, and so on. So, for example, you can say now I have deployed an application on EKS, and then that EKS, or if I deploy my pod on the EKS cluster, that pod now want to make, or that pod want to connect to a database running on the AWS, something like that, right? So it has to identify that the request is coming from the given pod only. So that is why it is very important to identify the given workload, correct? uh, uh, for that to be done. So what has been mentioned here is we can do this by putting up the network identity for each of my application. I can do that, and also we can put service accounts uh, to identify the given workload as well. So these two things are being mentioned here, which we'll try to look at in the coming part. Yeah. Yeah. So, yeah, so one of the way you can do it is by doing the shared secret. Now, what does that mean is, let me just get my notes here. Mm. Yeah, so I think at a high level, what does it mean that your client knows about the server and server knows about the client, that whom I am talking to on and who is doing the connection with me. So you kind of do it with this method of shared secret, in which the client and server knows about each other. But now the problem is, let's say initially make the connection that you may have done by some means, right? But now if you rotate and or upon expiry of a given secret, right? How do you again make sure that the connection between the client and server is not compromised, correct? That is what something is being mentioned here. Hope this makes sense, right? So you have a client, you have a server, they verify themselves initially by some means. Now rotation happens of set of secrets and so on. Now how would you trust, or how would you exchange that same verification, correct? And that is the problem what is being mentioned here. The problem which is mentioned here is called as the yeah, this problem is right. This is, they call it receiving problem. So they mentioned that they'll talk about this thing later in the book. So we'll come back and revert that particular point here, that how would you make sure that when you do the rotation or the expiration fixing of the of the secrets, how it is going to be resync um, mutually. That is the point. So we'll touch upon this later as the book covers in the later pages there. Um, yeah. So then talked about network identity. So as we know that, right, within the given network, we have IP addresses, um, MAC addresses, and so on, which we can somehow say that it is a given identity of a given endpoint. But in terms of Kubernetes, as we know, pods keep come and go very frequently, right? So it becomes more challenging if you want to use the existing solutions like IP addresses and other stuff to identify a given endpoint. Because if the pod dies, new pod comes with a different IP address. How would you now guarantee that it's the same identity or it is the same workload what was running earlier? Correct. So that can be a bit challenging. Um, there. But to solve these things, so we cannot use the typical like IPS methods to identify a given workload. we should do something more, correct? And for that purpose, the different CNI plugins have some methods of identifying a given workload uniquely. So for that purpose, two examples are being given here, one with the Calico and another with the Cilium, right? So now why we should care about kind of a say putting this kind of identity in place. So think about, you want to allow the incoming connections only from a given endpoint. So as I mentioned earlier, right, you have a payment and you have logistic, right, and some other microservices running in the environment. So you want to make sure that when the traffic is going from the, let's say, order to payment, it is going to the right payment endpoint, for example, correct? Or you want to allow, let's say there are multiple namespace you have, and different namespace have different payment services running. Now you want to make sure that the payment endpoint of this namespace, whatever I am in right now, should be available by the logistic or the order service running in my namespace only, not from anywhere else as well. So how would I basically enforce that? That I want to put this network policy in place. To do any of these things, I need to make sure that I am able to identify the endpoints correctly. Only when I can do it, I can put these policies in the enforced mode, correct? So I believe you would have used network policies in Kubernetes. I think it was covered earlier in this chapter, but in this book, I'm not too sure. But like this example of this policy is being given here. But this policy is being configured via the CNI plugin. So there are network policies which are the Kubernetes object based or Kubernetes default object endpoints. But here we're talking about these policies are being done on top of the Calico CNI. There is a difference only here because we are putting up the global network policy. So if I just try to look at this policy once, then we can go back and then try to see how it is being done. So what we are saying here is, I am putting a network policy with the Calico with the name of summary. And what we are saying here is, this policy, which is summary policy, is applicable for um, all the applications which have um, the label app is equal to summary. So I am putting this summary policy for all the applications which have label app set to summary. And for all such applications, ingress, the incoming connection is allowed from the service account, um, from the service account called customer, and from the namespace app is equal to bank. So I'm saying that I'm going to allow the incoming connection to all the apps which have label app set to summary. The incoming connection is allowed only from the namespace with the label of app is equal to bank, and then I'm going to allow only the customer service account to take the incoming connections, correct? This is a policy I am putting up with the help of Calico here. Now, how it is being done here in terms of Calico? So this example is being given with the help of Calico and Istio together, correct? So that's the example what has been given in this book at this point of time when it was written. So look at sorry. So we are referring to the point when this book was written, like 3 to 4 years back. But I think now there are better approaches out there right now. So what has been assumed here, that on this particular cluster, whatever is there, there is Istio being configured, and then there is a Calico CNI is being installed. Now, as you know, if you use Istio, it kind of inserts or in the default or in the mode which was there when the book was written, that there was a sidecar container that get inserted, correct? When you deploy Istio, I believe you are aware of that, right? That when you deploy this service mesh called Istio, it creates a sidecar container on every application. So what you can see here, there is this pod A and the pod B. This is the application client app, server application, perfect. But along with that, there is this envoy sidecar proxy. This sidecar proxy basically does all the magic of Istio, how to transfer the data and all those stuff as well. What is the what you call it, delay, or what is authentication, and all those things I have to do. So what you are seeing here is something called as mutual TLS. Mutual TLS is MTLS, what is being mentioned here. Now, what is mutual TLS? It is saying that both parties verifies the certificate of both the endpoints. That's what I can simplify in terms here. So now this is being done behind the scene via the Istio itself. So when you configure Istio, it would bring up this MTLS feature, using which each of those endpoints can connect to each other securely, correct? That is happening automatically. So now what is happening, this MTLS feature is being given to you via the Istio itself. That is part one to it, right? Now, second thing, what is happening here is the I just need to go through it. No, it's kind of a bit confusing, but I'll just try to simplify it. Let me see. Yeah, now to basically have these kind of rules in place, right? That I want to allow only from this namespace, I want to select only these things. What has been done here is Calico inserts another sidecar along with the app what you have, and there is this Felix component of the Calico. If you're not aware, I'm not too sure how to describe that, but it is kind of trying to make the connection. So Felix, I believe, configures the route that who can connect to whom and all that stuff. That is what the Felix job is. So along with this cats, whatever is being called here, now this is particular is done with the help of this cats and the Unix socket what has been configured there. So at a very high level, because I don't think it's kind of an interesting topic to cover anyway, but what has been discussed here is at a very high level that if I use Calico with Istio, that's a must condition here. So if I'm using Calico and Istio together, I can verify that first of all the connections happening between the two endpoints are happening to the right workloads, and then I'm able to put up these kind of rules which I want to add up here, that allow only from here and all that stuff to happen. I can use the method of Calico, but I don't think we kind of need to go into much of into it. But I'll talk about Cilium, which is much more simpler, and it does not require Istio to be present here. So Istio, only if you have Istio, then you can perform the previous method, which is another overkill. But if I am using Cilium, which is another CNI, so if you have used CNIs, if you have used the Cilium earlier, you know that in the Cilium, we can assign the unique endpoint ID to each endpoint what we have configured, and then similarly identity as well. So what is happening, as you can see here, like you can see here 1597, this has been given to 4 pods, right, of a same deployment maybe, for example, right? I'll talk about the 5th one here in a minute, but first let's focus on these first 4 here. So for first 4 of these pods, the identity is the same and their endpoint ID is different. So what's happening is when you create any object in Kubernetes with Cilium, you get a unique endpoint ID, right? And now that endpoint ID is sufficient to identify a given endpoint in the entire network. That is the first thing. Now, what we are doing here is all of these four pods, which are being given here 1597, they all have the same kind of labels. That is, they are part of one group. But only for the fifth pod, we have given one additional label, label selectors, if you know, right? So now because we have given additional label to the fifth pod, it has got different identity ID itself. Correct? So what I'm trying to convey here is within the Cilium, it is very easy to identify which endpoint I am talking to, because it gives a unique endpoint ID to each endpoint what you're going to get. And now when that packet travels in the network there, you know that the Cilium uses ePBF. Now Cilium also has support of ePBF, but that's another point of discussion. But Cilium is primarily built on ePBF. Now when the packets are going to and fro, and if I can identify the endpoint very uniquely, I can set up all of these policies in a much more simpler way. So we are not dependent on anything else, correct? Because these endpoints are unique in the given Kubernetes endpoint and cluster what I may have. And that is why this makes much more sense. And that is what has been mentioned here, that because each endpoint is given a unique ID and identity as well, if we can kind of group them the way it has to be, then I can easily build these policies, correct? And that is how the Cilium works behind the scene, because it can identify each endpoint uniquely. Make sense?
Yeah.
Yeah. And again, I may be wrong. So of course, if you can, verify my thing, what I'm telling you also, that would be also, useful, right? I did my best to kind of explain it, but as it's a book reading, I others to also kind of read and come back and comment, right? That would be ideal. Okay. So then, of course, we are at our 9 p.m. at least for the India 1 hour. What we have blocked for this thing is done. And to be honest, I kind of done till this SAT more. Other than that, I have not covered the remaining book, remaining chapter. So what it will try to finish the next time. So next time we'll definitely finish um, this particular chapter, which is of identity. And the next one we can have to go with, the next one is chapter 11, which is the building platform services, right? This is going to be very interesting because now, platform engineering is coming up. All the platform engineering base would be given here, I believe, right? So very interesting, I believe. If anybody wants to pick up that book chapter, I will be more than happy to kind of have you as a main kind of a say person to deliver the content. But at the same time, as a book reading, we all go and read this chapter and come back. So you still have like 2 weeks to kind of pick up this particular chapter. So if anybody want to volunteer for this, you can tell us right now or later, whichever works. But yeah, it would be better if somebody else pick up the next chapter, so that yeah, it's like a kind of a community effort there. Yeah. Any volunteer want to take the lead?
Nipanja, I would like to give it a shot, but
Cool.
just
We'll support. Don't worry, man. We'll support you
I
completely.
I have to just also check if I don't have anything conflicting during this time at my work, so I
Okay.
can be fully present. But I think I would like to give a shot to this one.
Cool. Yeah, it's very important. It's going to be very interesting as well. And I think, as we know, that 24 is going. Next year, this year is going to be all about platform engineering only. This would build a solid foundation for us for sure. Yeah. Okay. Cool. Let me know, Valdemar, by the next week so that we can confirm that. Okay. So next week, I'm expecting that you all of us go back and read this chapter, come back and have more discussions, right? Kind of one way we want to have as a group discussion, that would be better. Yeah. So thank you
Yeah,
for
it's always
inviting.
good if everybody kind of reads it and it's a discussion
Yeah.
rather than a teacher-student kind of setup.
Correct. Yeah. So that's
Yeah.
all I think it happens. If you are regular, then definitely it would happen. And I'm sure that now whatever the chapters we have in this book, they are very interesting, and then they are going to, of course, play an important role. Like for example, today is this impersonation, right? It's a very important concept of production, correct? So only by reading the books like this we can get to those core things, right? Okay, I think with that, we'll kind of finish up our first session of this year. Let me quickly take a quick screenshot of this so that we can just do a bit of marketing for the first session of this year. Okay, see you guys next time, next Thursday. Yeah, looking forward for it. Yeah, okay, see you guys. Bye bye.
Thank
See
you.
you.
Thank you.
Bye.
Happy New Year, everyone. Bye.
Hope it was useful. Bye bye.